Welcome. My name is Victor Rubicari. Today we will be measuring the maximum acceleration of an elevator using Newton's second law of motion. I am in the Brophy Eller elevator, which has a capacity of 5,000 pounds on the first floor. It also has 3 floors total. On the first floor, my initial weight is about 160 pounds. While I'm at rest in the elevator, there are 2 forces acting on me. Force of gravity going down and normal force going up, as you can see in my free body diagram to the right. Weight is associated with gravity, and to find the force of gravity, which is actually measured in newtons, we have to start off with my initial weight in pounds. I was initially 160 pounds, and I converted that to kilograms to find the mass, because mass is what we use when we talk about forces along with newtons. And to find the mass, I took my initial weight and divided that by 2.2 kilograms, and I got a mass of 72.72 kilograms while I was at rest. And I took that mass and converted that into newtons by multiplying it by 10, which is the acceleration of gravity it's just the acceleration of gravity either going up or down. And the force of gravity acting down upon me came out to be 727 newtons total. And to find the net force of me at rest, you can take the normal force and subtract that by the force of gravity. And because there are no other forces acting upon me, those 2 forces are equal. And so we get a net force of 0. That is actually Newton's first law, which states that an object in motion will stay in motion and an object at rest will stay at rest. And I am an example of that. I was at rest on the elevator, and so my net force was 0. This is my 3rd trial, going from the 1st floor all the way up to the 3rd floor. As I went up the elevator from the 1st floor all the way up to the 3rd floor, my normal force was no longer equal to the force of gravity, because I was no longer at rest. I was accelerating upwards in the positive direction. And so initially on the scale, my weight changed for a small moment. And so my weight came out to be 764 newtons, as you can see in the free body diagram with the normal force. That's what was pulling me up. And so because I was accelerating positively, I needed to find the new net force. And so I took the normal force, what my weight changed to be, and my initial weight, and I took the force of gravity and subtracted that from the normal force, and my new net force during that small period of acceleration came out to be 37 newtons. And so I used that to find what my actual acceleration was. And to find that, we use Newton's second law, which is net force equals mass times acceleration. And because we're trying to find acceleration, we divide mass over to the other side, and so the new equation comes out to be acceleration equals net force times acceleration equals net force divided by mass. And as we came to solve earlier, my new net force was 37 newtons, and I took that and divided that by my my initial mass, and the same mass that I kept throughout this whole experiment, which is 72.72 kilograms. Sorry. And taking that, plugged it into my calculator, and my acceleration going upward came out to be 0.508 meters per second. That is because I accelerated because my normal force was greater than the force of gravity acting down upon me, causing. As I'm still going up, this is a calculations for that small moment where I start to accelerate in the negative direction so that I can ultimately return to a net force of 0 because the elevator was coming to a stop. And to figure that out, I did the same thing as before. I examined the scale and looked at how my weight changed during that small period of negative acceleration, and found again the new net force during that period. And that net force came out to be negative 59 newtons. I took the negative 59 newtons and plugged it into the acceleration formula, which was again net force divided by mass. And with that, my new acceleration during that small period of time while I was coming to an end, while I was coming to a stop from my upward elevator trip, came out to be negative 0.81 meters per second. It is negative because, again, I was accelerating downward so that my normal force can ultimately come back to be equal to the force of gravity. In this, my normal force isn't equal to the force of gravity because, again, I was accelerating downward, but it was all part of a process to ultimately get me back to that state of rest so that I can ultimately get off the elevator and end my trip. This is my fourth trial, going from 3rd floor all the way down to 1st floor. Here are the calculations for when I went down the elevator from the 3rd floor to the 1st floor. At first, there was a negative acceleration, of course, because that was the only way that I would be able to go down. And during that small period of negative acceleration, my weight changed to be 650 newtons. And my new net force during that small period of time came out to be negative 77 newtons. I took that negative 77 newtons and again put it into the acceleration formula, and the acceleration during that small period of time in the beginning of my trip down was negative 1.05 meters per second squared. My force of gravity was ultimately bigger than the normal force because that was the only way that I would get pulled down. If the normal force was equal to the force of gravity, then I would be at rest, and if the normal force was greater than the force of gravity, then I would be going upward. But since it wasn't, and the force of gravity was greater, I was able to go down the elevator. After the initial negative acceleration, my net force went back to 0, and I was at a constant velocity as I went down the elevator. And now my calculations for the moment where that came just before I ultimately came to a stop on the elevator. That right before I right before the elevator stopped, there was a positive acceleration for a small period of time that ultimately brought me back to the zero net force. And during that positive acceleration, my force of gravity stayed the same, and my weight changed to ultimately become 768 newtons after all the calculations. And my net force during that during the positive acceleration while I was still going down came out to be 41 newtons. I took that, put it into the acceleration formula, and ultimately got an acceleration of 0.56 meters per second squared as my acceleration as I was going down the elevator, but my acceleration was going up right before it came to a stop. This again helped me come to a stop, and my normal force was greater than my force of gravity, which prevented me from going down, from continuing to go down the elevator. The normal force would help me come to, again, and help bring me up so that I can ultimately come to a net force of zero. As you can see, we received different accelerations for each trip. When we're going up from the first floor to the third floor, we got a positive acceleration of 0.508 meters per second squared and a negative acceleration of negative 0.81 meters per second squared. And during our upward trip, the maximum acceleration was in the negative direction of, and it was negative 0.81 meters squared. While we were going down from the third floor to the first floor, the negative acceleration was negative 1.05 meters per second squared, and the positive acceleration was 0.56 meters per second squared. And the maximum acceleration while we were going down was again negative 1.05 meters per second squared. That came out to be the maximum acceleration of the whole elevator trip throughout all of our tests. That is what came out to be the maximum acceleration, whether going up or down. I believe this is because the force of gravity and the force of acceleration were all going in the same direction, and since the Earth is already pushing down on us, the elevator added another force pushing down on us, which was the negative acceleration, making again the overall maximum acceleration of the whole elevator trip going downward the highest. Thank you for watching.